There might be times where we're asked to find a probability distribution for a set of discrete random variables. Now, when we're given the information where they've gone out and they've actually sampled a group and they've given us a chart of the random variable values that can occur and the frequencies in which those random variables occurred in their sample, we can estimate our probability using our relative frequency estimation of the probability. Other times, if we have exact probabilities, we would want to use those. So what I'd like to show you an example of here is where we have a set of discrete random variables and frequencies from a survey that was done, and how we would go about answering questions about making a probability distribution, graphing the probability histogram, then also finding the expected number and standard deviation for the distribution, and an application question that goes along with it. Now, in this example, we have a small college where the professors were surveyed, randomly selected and surveyed, and asked how many books they require for their course. And when the information was recorded, there were 2 professors that replied that they don't require any books for their course. There were 41 professors that responded that they require 1 book for their course, 36 that responded and said they had 2 books for their course, and 1 professor that responded saying that they required 3 books for their course. And when we then are asked to find a probability distribution for that information, what we want to do is list the random variable values that can occur and the probability that those random variable values might occur if you randomly select one and looked. And notice that it's really important to look at the word in front of distribution, because if it says a frequency distribution, that's what we had in the information above. You've got your random variable values and your frequencies. If it says a probability distribution, then you want your random variable values and their probabilities. So that's what we want to do here. So we're going to list down each of our random variable values. And again, we're going to just use our relative frequency as an estimation towards the probability. So we have a frequency of 2 that required 0 books for their course out of the total number of professors that were surveyed. So 41 plus 36 is 77. So 78, 79, 80. So 2 out of 80. And then that required 1 book for their course, it's 41 out of 80. That required 2 books for their course, it's 36 out of 80. And then 3 books for their course, it's 1 out of 80. So then looking at this, we'll want to see what we have in terms of our decimal approximations or values. And with probabilities, again, usually we use 3 significant figures when we're giving our values for our probability. So 2 out of 80 is 0.0250 for our 3 significant figures. And then for 41 out of 80, it's 0.513. For 36 out of 80, it's 0.450. And for 1 out of 80, it's 0.0125. So each of those are our decimal values for it. Now, when we want to then draw a histogram, a probability histogram, we want our horizontal axis to be what our random variables represent. So here's the number of books per course. And because we're shifting 0 out away from the origin, we're going to show a break in the curve to represent that. So we have our 0, our 1, our 2, and our 3 from the values that the random variable can take on within this problem. And then because we're doing a probability histogram, our vertical axis needs to be denoted as probability of x. And we looked at what the decimal representations are for the probabilities that occurred within the situation, and it topped out at 0.513. And so when I looked at how I was going to segment off the grid in order to draw this, I knew I needed to get at least to the 0.55 before I ran out of space on my grid. So I just looked at some different equal increments that would do that for me. But be sure that you keep equal increments along so that you don't distort the histogram when you draw it. Okay, so each of the heights of the bars are going to be the probabilities of that random variable. So for the bar above 0, we're going to have a height of 0.0250. So match up the decimals. 0.02 is smaller than 5. The first place they don't match. So it's going to be shorter than that, and actually it is going to be just up to 0.025 is half of 0.05. So I just went up half of the way to it. Okay, then for our one book that's required, it's 0.513. So we have 0.513 is about there, between 0.50 and 0.55 for our heights. For two books, it's 0.450. So my bar that's above 2, I do a height of 0.45. And for the bar above 3, it's 0.0125. So that is a quarter of the way up the 0.05. So we just kind of shade those in a little bit better. And that is our histogram of our probability distribution. Remember, for a histogram, the bars have to be the same width and they have to touch. And we have our representative values along the horizontal axis for our random variable values. And for the probability histogram, the probabilities along the vertical axis. Okay? Now, the third part is how to find the expected number and the standard deviation. Now, the expected number is the same as the mean. So, for the expected number or the mean of a probability distribution, you take each x times its probability. So, each random variable gets multiplied to its probability, and you do that for each of the values. So, you'll go 0 times 0.0250. Then you'll go 1 times 1 times 0.513, 2 times 0.450, and 3 times 0.0125. And once you get all those products, you're going to add them up. So that's your expected value or your mean. And then the standard deviation of the probability distribution, we have our formula for that as well. But the thing that I want you to do in terms of finding these is actually use the operations on your TI-83 calculator for the stats class so that you can see how to work that as well. If you're learning from someone that wants you to use the formulas, then you would want to run all these values through the formulas. So I'm going to take the formula off of the mean and just write out what we would need to do on the graphing calculator. So find the stat button, push stat. And then when you get to the stat menu, you want to push or be on edit and push enter. And you'll get a list 1 and a list 2. So then under list 1, you put your random variable values. And in your list 2, you put your probabilities. Now, once you do that, push the stat button again and cursor one right to where it says calculate. So we're going to push the stat button again, then calculate. And the first choice is 1 var stat. And that'll be highlighted, so just push enter. And once you push enter on that, it'll give you a 1 var stat in your operating screen, but will be like paused there. So what you want to do is tell it that the random variables are in list 1 and the probabilities of those random variables are in list 2. So it accesses both lists. So you need to push the L1 and then comma the L2. Now the L1 is the second function above the number 1, down where you enter your numbers. And then the comma is right above the 7. And then the L2, you do the second function key and the 2 button, and that's your L2. And once you do that, push enter. And when you see that, you'll get a mean of 1.45. And you'll get a standard deviation, sigma sub x, of 0.0